This video accompanies the 2-1 student companion. We'll do the explore reason, and then we'll discuss the triads that are in this section. And this is all about parallel lines cut by a transversal. So let's look at number 1 here. We got 2 parallel lines cut by a transversal. So what relationship among the angles do you see is the question. If we have parallel lines cut by a transversal, certain pairs of special angles have relationships. But assuming that we don't know that yet, since this is the beginning of the section, let's just kind of look and see what apparent relationships. Let's kind of modify this a little bit. What apparent relationships among the measures of the angles do you see? So it looks to me as though, like, we use angle 1 as a reference. It looks like the measure of angle 1 is the same as the measure of angle 5. They look the same. And let's see, so we got that. And since 5 and 7 are vertical angles, we could say that angle 1 is the same as angle 7. So we got these angles appear to be congruent to each other. And then angle 3 is also congruent to angle 1 because it's a vertical angle. So the angle angle 3. So angle 3 and angle 1 are congruent because of vertical angles, but 1 looks to be congruent to 5. These are in corresponding positions, left of the transversal, above the parallel lines. 5 and 7 are a pair of vertical angles, but 1 with 7 is what we would call alternate exterior angles. They're all alternate sides of the transversal. One's on the left, one's on the right. In exterior, they're outside the parallel lines. 1 is above the top parallel line, 7 is below the top parallel lines. That makes these alternate exterior angles. So these angles all appear to be congruent to each other, which means that 2, 4, 6, and 8 are also going to have a similar argument as to why those angles have the same measure also. Let's look at part B. Suppose a different transversal intersects the parallel lines. We'd expect to find the same relationships. So let's do parallel lines here. And let's do the transversal going this way now. So we got 1, 2, 3, 4, 5, 6, 7, 8. So I changed the angle of the transversal line a little bit, and these are the parallel lines. Again, it looks as though angle 1 is going to be congruent to angle 4 because of vertical angles. It looks as though angle 1 and angle 5 are congruent. They're corresponding. 5 is congruent to 8 because of it being vertical, but 1 and 8 then would be congruent because of alternate exterior angles being congruent. And it also looks as though we could say that 4 and 5 are also congruent because those are alternate interior angles. These appear to be congruent. So I missed that. Angle 3 and angle 5 are congruent. Those are alternate interior angles. Okay. So we would expect to find the same relationships if the angle of the transversal was changed up. Let's move on. Okay, example 1, we want to identify angle pairs. Which angle pairs include the named angle? So we're talking about angle 4 here is our reference angle. Well, angle 2 is a vertical angle, VA for short. Angle 5 is an alternate interior angle with angle 4. They're alternate sides of the transversal inside the 2 parallel lines. Angle 4 and angle 8 would be corresponding position. They're same side of the transversal, left below the lines that are crossed, so they're corresponding angles. So we got 4 is a vertical angle with 2. 4 and 5 are going to be congruent because those are alternate interior. 4 and 8 are in corresponding positions. And 4 and 3 and 4 and 1, angle 4 and angle 3 and angle 4 and 4 and angle 1 are linear pairs, which means they're supplementary. Their measures add to 180. So those are relationships that we can see in this diagram that angle 4 has with the other angles in the diagram. Now, if parallel lines are cut by a transversal, alternate interior angles are congruent, corresponding angles are congruent. Same side interior angles are supplementary. So we could also say that angle 4 and angle 6 are supplementary. And we would abbreviate that with same side interior angles being supplementary. Same side of the transversal inside the lines that are crossed. If parallel lines are cut by a transversal, same side interior angles are supplementary. Okay, let's look at example 2, try it. They tell us that angle 4 is 118 degrees. What's the measure of each of the other angles? Well, let's just kind of use what we have. Vertical angles gives us 118 there. 3 and 4 are a linear pair, which means that 3 has to be 62. And either by linear pair or vertical angles, we can get angle 1 is 62. So that's what we can do at this intersection here. Now, if the lines are parallel and cut by a transversal, then corresponding positions are going to be, corresponding angles are going to be congruent. That means angle 4 and angle 8 are going to be congruent. That puts 118 with angle 8. By vertical angles or alternate exterior angles, we can say that 4 and 6 are going to be 118. Alternate exterior angles are congruent if you have parallel lines cut by a transversal. Corresponding angles are congruent if you have parallel lines cut by a transversal. Alternate interior angles, 2 and 8, are congruent if you have parallel lines cut by a transversal. And that leaves, 5 and 3 are alternate interior angles, so I could jump the 62 over to 5 since they have to be congruent, or I could do linear pairs with 6. And the same thing here, 7 could be 62 because of vertical angles, or it could be 62 because of being a linear pair with 8, or it could be 62 because of being a linear pair with number 6, or it could be 62 because it's in corresponding position with angle 3. So we got those. Let's look at B. If the measure of angle 2, so we're talking about angle 2 now, and angle 4. Now angle 2 and angle 4 are a pair of vertical angles, so these are going to be congruent to each other, which lets me set their measures equal. So 9x minus 12 is equal to 6x plus 30. So take away 6x from both sides and add 12 to both sides. 3x's is 42. X is going to be 14. Now they want to know what the measure of angle 5 is. Let's look. Angle 5 is the same side interior angle with angle 2. So angle 5's measure is going to be supplementary with angle 2's measure. So we need to find out what the measure of angle 2 is, which is 9 times 14. Take away 12. 90 and 36 is 126. Take away 12 gives us 114. So the measure of angle 5 is 114 because angle 5 and angle 2 are supplementary since they are same side interior angles. And we got that they're equal to 118 because the measure of angle 1 is equal to the measure of angle 2. So from the algebra, we found out that x was 14 to make those equal to each other. And when we plugged it back in, we could have also done this way. 6 times that gives 84, plus 30 also gives 114. So either substitution, we get 114. Okay, let's look at example 3. Prove the corresponding angles theorem. So let's do this as a 2-column proof, statement, reason. And I'm thinking, okay, so we want to prove that 1 is congruent to 2. We've got 1 and 3 are supplementary because those are linear pair. We've got 2 and 3 supplementary because those are same side interior angles. And then congruent supplements is going to let us say that 1 is congruent to 2. So let's see, we got measure M parallel to N is given. Okay, let's note that measure angle 1 equals measure angle 2. No, we can't use that. That's corresponding angles. We're trying to prove that. Let's do measure angle 1 plus measure angle 3 equals 180. Linear pairs are supplementary. LP R linear pairs are supplementary. And let's see, what else do we have here? 1 and 3 are supplementary. 3 and 2 are supplementary because those are same side interior angles. So measure angle 2 plus measure angle 3 equals 180. And the reason for that would be same side interior angles are supplementary. The full statement is, if parallel lines are cut by transversal, then same side interior angles are supplementary. We got 180 equal to 180. We can set these equal to each other by, this would be transitive property for 4, since 2 is equal to 180, and since 3 is equal to 180, we could put 180 equals 180 and substitute, or we could just connect these together because they're both equal to the same thing and end up with measure angle 1 plus measure angle 3 equals measure angle 2 plus measure angle 3, and that would be transitive property. And take away measure of angle 3 from both sides. We got measure angle 1 equals measure angle 2. And then that would be subtraction property of equality. And then for step 6, angle 1 is congruent to angle 2, and that would be definition of congruent. Let's look at example 4. We want to show that, let's do show angle 1 and angle 2 and angle 3 is 180. Well, angle 1, measure angle 1 equals 90, and that is linear pair. Well, it's a right angle. Right angles are 90. Angle 3 and 4, measure angle 3 plus measure angle 4 equals 90. That's definition of complementary. Let's see what else we got. By alternate interior angles, angle 2 is congruent to angle 4. Measure angle 2 equals measure angle 4, and that's alternate interior angles are congruent. So that gives us that 2, if we substitute in to here, we have, since 2 and 4 are the same thing, if I put 2 in place of 4, I've got measure angle 3 plus measure angle 2 equals 90. That would be substitution. And if we had angle 1, we got measure angle 1 plus measure angle 2 plus measure angle 3 equals 90, plus the 90 from measure of angle 1 equals 180. So basically we can show that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. So like this last one down here, I got these parallel lines, EJF. EJF is 56. And we want to find FHK. FHK, we want to find this angle measure right there. So let's see what we got. These lines are parallel. So let's see, what could we do? It's not going to help us much there. With these parallel lines cut by transversal, this 68 and angle 2 are corresponding positions. That's going to be 68 degrees. Let's see, that's going to let me find this other angle here. See, parallel lines cut by transversal, corresponding angles are congruent. Let's see, if we do this as the transversal, we got alternate interior angles are congruent. This is going to be 68 degrees here. By vertical angles, 3 is going to be 68 degrees. Let's see, we got parallel lines cut by a transversal now. Parallel lines cut by a transversal. That's not going to help with that. Let's see what else we got. These parallel lines cut by a transversal. Let's see what we got. Well, let's see, 68 and 68. Okay, 68 and 56 is 124. 124 from 180 gives us 56 degrees for this angle here. And we can figure out what this angle here is now. I don't know if it's going to help us or not. 56 and 68 is 124. That means this is going to be 56 degrees here. This has to be 360 because it's a quadrilateral. I don't know if that's going to help or not. Let's see what else we got. That's a 68. Okay, here, JC and KD, alternate interior angles. Let's put a 56 down there. Now this is a linear pair, which means they're supplementary, so 180 take away 56 gives us 124 degrees. So the measure of angle FHK equals 124.